Hello guys, I'm here before you with a new explanation video about a very basic topic in geography, which is the composition and structure of the atmosphere. I guarantee you that this will be the most simplest explanation which you have ever heard, and I will be happy to hear your queries and if possible solve them as soon as they get to me. Okay. First, you have to understand that our atmosphere is composed of not only gases, but water droplets and dust particles are also a part of it. A continuously repeated topic in examinations, this part needs to be focused more. You gotta understand a surprising fact that 99% of the atmosphere is occupied by two main gases, which are nitrogen, which has a composition of 78%, and oxygen, 21%. Now, out of the remaining 1%, 0.93% is occupied by argon, which is an inert gas just like nitrogen and thus do not get involved in any chemical reactions. Thus, it will be shocking for you to know that water vapor, carbon dioxide, and ozone has only less than 0.1% composition in our atmosphere. These gases are thus called trace gases, and the percentage composition of carbon dioxide is 0.0325%. Both carbon dioxide and water vapor are greenhouse gases. Next section of our video is structure of Earth's atmosphere. Earth has 5 layers of atmosphere extending from the surface of the Earth to the area into the space. The main layers of Earth's atmosphere are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere extends from the surface of the Earth towards an average height of 10 kilometers, stratosphere from 30 to 50 kilometers, and mesosphere extend from 50 kilometers to 85 kilometers, and thermosphere from 90 to 700 kilometers or 1000 kilometers. And the last layer, exosphere, extends from 1000 kilometers to outer space. I'll be giving you detailed explanation of all these layers and you will see the important points mentioned in my slides. Also, you will be provided with tips and memory techniques which I know regarding this topic. Alright guys, let's move on to the detailed explanation of all these five layers. Let's get into the layers in detail. The first layer of the atmosphere, named troposphere, is considered to be the most important layer in view of entrance examinations and in general because this is the layer nearest to the surface of the earth and most of the weather conditions occur here. Thus, it is the layer which has been studied the most, and we have found that all our familiar weather phenomena like cloud formations, rain, thunder, lightning, etc. occur here. This layer has an average height of 10 kilometers, and this height varies at equator and at poles, and we can get a different height also during summer and winter. The point which I have just told you needs to be given special attention because this is a concept which the entrance test makers love the most. So listen carefully guys. Troposphere has a maximum of 20 kilometers at equator and 7 kilometers at the poles, and also its height is the highest during summers and lowest during winters. Since 99% of the total mass of water vapor and aerosols is found in this layer, this is the wettest layer. Also, take note that 75% of atmospheric mass is contained in this particular layer. Troposphere has the warmest air at the bottom, and as we go up, it gets colder. This is the explanation for peaks of tall mountains covered in snow even during summer. Similarly, as we go up, the density also decreases. This is also a very important point because the reason why cabins of jet aircrafts are pressurized lies here. Okay, before moving on to our next layer, you take note here that there is a transition between troposphere and stratosphere, which is the next layer, and this transition is called tropopause. The second layer following troposphere is the stratosphere. This layer is famous for its ozone content and thus becomes an important section in exams. Questions have been repeatedly asked regarding this topic, like in which layer of the atmosphere can we see the presence of ozone? Okay, ozone is abundant in this layer. As we move upwards, temperature increases in this layer. Ozone's presence has a lot to do with this phenomenon. Ozone absorbs the incoming ultraviolet radiation, thus increasing the temperature. Because ozone absorbs the ultraviolet radiation and thus the temperature of the layer is increased. This is a very dry layer because of the absolute absence of water vapor. The reason why commercial jet aircrafts fly in the lower stratosphere and not troposphere is because of the stability of air layer of the stratosphere. In troposphere, there is heavy turbulence, but in stratosphere, because of the stratification, there is a very little convection and mixing, resulting in a stable air layer. Also, jet aircraft and weather balloons reach the maximum operational altitudes within this layer because of the very thin air here compared to sea level. Okay. Now, because of the lack of vertical convection, whatever materials coming to the stratosphere get stuck in there for comparatively longer time, which is the reason why the chlorofluorocarbons which once stuck in stratosphere destroys the ozone to its maximum. Another fact which is very important is the presence of blue jets, which are rare electrical discharge similar to lightning, and these blue jets are only seen in the atmospheric layer. Now, moving on to the third layer, which is mesosphere. Here, temperature decreases as we move upwards, just as in troposphere. Coldest temperature in Earth's atmosphere is found near the top of this layer, which is negative 90 degrees Celsius. Not much is known about this layer because satellites orbit above mesosphere and weather balloons cannot cross stratosphere. Thus, we have limited access to this mesosphere. Most meteors soon after entering this layer gets vaporized. Also, we have known that this layer is very dry. Plus, there's an extra information which is stratosphere and mesosphere together is called middle atmosphere. Okay, because both of these layers come somewhat in between. Now, moving on to the fourth layer, which is thermosphere. Thermosphere, as the name suggests, is extremely hot in comparison with the other layers. Temperature climbs sharply in lower atmosphere. Solar activity strongly influences the temperature in this layer. During daytime, this layer is 200 degrees Celsius hotter. Air density is very low in here, and we have a temperature range of 500 degrees Celsius to 2000 degrees Celsius in the upper thermosphere. International Space Station and space shuttles orbit in this layer. Please note this point, it is very important. And finally, a very important phenomenon which we see as colorful display of lights called aurora occur in this layer. Aurora is the southern and northern lights. In northern hemisphere, these lights are called aurora borealis, and in southern hemisphere it is called aurora australis. The reason why this phenomenon is observed only in this particular layer is because charged particles like electron, proton and other ions from space collide with atom and molecules in thermosphere at high latitudes, exciting them into higher energy states. These shed this excess energy in the form of photons, which result in colorful auroral displays. Okay, that's all about thermosphere. Now we'll be moving on to our final layer, which is the exosphere. Now let's get into the exosphere. This layer is very thin, and this extends into outer space. Because of this reason, this layer is not considered to be a part of our Earth's atmosphere by some scientists. Usually, questions are not seen being repeated from this layer, so just listen now. Thus, okay, in exosphere, since this layer extends into the space, we don't have much information about this, and this is not considered as a part of our Earth's atmosphere also. Okay, now here I end my explanation on composition and structure of the Earth's atmosphere. I hope you liked my explanation. I'll be glad to clear your queries. Thank you so much.